Hi, this is Bradley Bush. Today we're going to talk about continuity of composite functions. Specifically, we'll talk about composite functions that happen to be trig functions, like cosine. So if you were asked to find the following limit, which would be right here, and then you were asked if the function being used in the limit, we'll call it h, which is right here, if that is continuous at c. And when we say at c, really what we're saying is this value right here, which is c. So how do we do that? What do we know about continuity and composite functions? Well, the answer is, given f of g, meaning you have two functions f and g is being used as the input into f, and we're given an x value, say a. If g is continuous at a, and if f is continuous at the output of g evaluated at a, which we'll call b, then the composite function f of g is also continuous at a. So let's say that one more time. Given f of g is your composite function, and g is the input to f. If g is continuous at a, then we plug a into g, and something comes out. We'll call that thing that comes out b. If g is continuous at a, and f, the outside function, is continuous at b, then the composite function itself, f of g, is continuous at a. So let's look at this a little bit. Again, we have a, which gets put into g as the input. Then we have something that comes out of g, and we're going to call that b. And that b is then put into f, the outside function, as the input. So there are two parts here. The first part will be when a is put into g. We need to know if that is continuous, if g is continuous at a. The second part is where b is put into f. We need to know if f is continuous at b. If those two parts check out, then f of g is continuous at a. So if we look at our function h, which is cosine of 4x minus cosine of 2x, we need to actually identify which is the f and which is the g, meaning we need to write it in terms of a composite function. So if we say that f is cosine of x, that's our outside part right here, and g of x is 4x minus cosine of 2x, which is the inside part. Let's check these two parts, the part 1 and part 2, see if this actually checks out. So for part 1, is g continuous at a? Now remember, a in our case is 15 pi over 4. The answer is, well, yes it is, because, and lucky for us, cosine is defined everywhere, and a linear function is defined everywhere. So it actually doesn't matter what the input is. Our function's continuous. Our function g is continuous. So that's a yes. That checks. G is continuous at a because doesn't matter what a is, g is continuous everywhere. So then what comes out of g once we plug in 15 pi over 4? That's something we need to know, because that we're going to call b. And then we're going to ask, is f continuous at this value, b? So let's first look at what g of 15 pi over 4 is. So let's plug in 15 pi over 4. We have some cancellation here with the 4s. We also have cancellation here. This 2 becomes a 1, and this 4 becomes a 2. Now the cosine of 15 pi over 2 is actually 0. So that just goes away. So all we're left with is just 15 pi. So our b value equals 15 pi. So we found out that g is continuous at 15 pi over 4. We plug 15 pi over 4 into g and we get 15 pi. Now we need to find out if f is continuous at 15 pi. Well, again, what is f? F is cosine of x, and we've already established that cosine of x is continuous everywhere. So it is continuous at 15 pi because it's defined everywhere. So we can then say that h is continuous everywhere, meaning it's continuous on the interval negative infinity to positive infinity. So we've answered the question, where is it continuous? Or is it continuous at 15 pi over 4? We've answered that question. Now we need to know what the limit is as x approaches 15 pi over 4. So this is our next question. What's the limit of cosine of 4x minus cosine 2x as x approaches 15 pi over 4? So let's use continuity to help us with this. If we know it's continuous, if we know h is continuous at 15 pi over 4, then that means that the limit exists at that point, and the limit at that point equals the function evaluation at that point. So to find the limit, all we have to do is find the function evaluation of 15 pi. So that's what we do. What is the function evaluation of 15 pi? Well, if we plug in 15 pi over 4. If we plug in 15 pi over 4 into h, again we get cancellations. And we know that this second term is 0. So all we have really is cosine of 15 pi, and cosine of 15 pi equals -1. So the function evaluation, h, evaluated at 15 pi over 4 equals -1, and that, because of continuity, is the limit of cosine 4x minus cosine 2x as x approaches 15 pi over 4. So we're done. We've found both of the things we were trying to find. We found the limit of h as x approaches 15 pi over 4, and we found out if h was continuous at 15 pi over 4. Thanks for listening. If you like, leave a comment and like the video. Thanks.